This is part 2 of this video where we are looking at more examples of rational inequalities. So let's solve x plus 5 quantity squared over x squared minus 4 is greater than or equal to 0. Everything is already on the left-hand side with 0 on the right. To find our zeros, let's set our numerator factor equal to 0, so x plus 5 equal to 0. Subtract 5 from both sides, x equals -5. That is our 1, 0. Now, before we try to find the undefined values, we need to factor the denominator. This is a difference of squares because x squared is a perfect square, 4 is a perfect square. It is a difference between the two, so square root of x squared is x. Square root of 4 is 2. One of these gets a plus, the other one gets a minus. So x squared minus 4 factored to x plus 2x minus 2. And we will set each of those equal to 0, x plus 2 equal to 0, x minus 2 equal to 0, and solve for x. So we'll subtract 2's in the first one and get x equals -2. We will add 2 in the second one to both sides and get x equals +2. So we have 1, 0, and one undefined value. So these are our critical values, -5, -2, and 2. And I wrote those in order from smallest to largest. So we will have an interval that goes from -infinity to -5, an interval that goes from -5 to -2, one that goes from -2 to +2, and finally one that goes from +2 to +infinity. We will choose a number in each interval. We will evaluate the left-hand side, and we will draw a conclusion. Okay, in my first interval, I'm going to choose -6. Again, you can choose any number in the interval. What we're interested in is whether using that number, whether we will get the left-hand side evaluated to a positive number or a negative number. My second interval, I will choose -3. I'll choose 0 in my third interval, and I will choose 3 in my fourth interval. Substituting in -6 for x, I get 0.03125. Substituting in, and what was important is that it's positive. It actually isn't all that imperative that you actually find the answer of what the left-hand side evaluates to. What is important is that you are determining whether it's positive or negative. When I substitute in -3, I get 0.8, which is positive. When I substitute in 0 for x, I get -6.25, which is negative. When I substitute 3 in for x, the left-hand side evaluates to 12.8, which is positive. And looking back at the inequality, we are interested in where it is greater than or equal to 0, so positive or 0. So the first interval, the second interval, and the fourth. And we do need to be careful or mindful of which of the values include a 0 versus an undefined value. So our solution will have -infinity up to -5. And -5 was a 0, so it's included with a squared off bracket. Union -5, which is included because it's a 0, up to -2, but -2 is an undefined value, so it is not included. Union 2, which is not included because it's another undefined value, up to infinity. And if you notice, these two intervals, from -infinity up to -2, there's nothing that's not included because -5 is included in both of those. So I can condense these two intervals down to one, which is -infinity up to -2. And -2 is not included because it's an undefined value. And then union 2 to infinity. So that would be a better way of writing the solution. Okay, let's look at another problem. x minus 4 over 2x plus 4 is greater than or equal to 1. Here we do need to move everything to the left-hand side so that 0 is on the right. So I will subtract 1 from both sides. And I get x minus 4 over 2x plus 4 minus 1 is greater than or equal to 0. I want the left-hand side to be a single rational expression, so I need to combine these by getting a common denominator. That will be 2x plus 4. So my first expression stays the same, x minus 4 over 2x plus 4. My second expression, because my original denominator was 1, I need to multiply both the numerator and the denominator by 2x plus 4, so my numerator is 2x plus 4. This is equivalent because 2x plus 4 over 2x plus 4 is 1, which is what we originally had in that spot. That's greater than or equal to 0. We can combine in one fraction. We have x minus 4, and now you're distributing that negative because it's between the two fractions. So minus 2x minus 4 over 2x plus 4, and that's greater than or equal to 0. Okay, let's combine our like terms. X minus 2x is negative x. Negative 4 minus 4 is negative 8. That's over 2x plus 4, and that is greater than or equal to 0. Okay, I could factor the denominator, but it's not going to give us something that will reduce with something in the numerator or simplify or cancel out. So let us now find our zeros by setting our numerator equal to 0. Negative x minus 8 equals 0. Add 8 to both sides. The opposite of x equals 8. Divide both sides by negative 1. X equals negative 8. So we have 1, 0. Let's find our undefined value by setting our denominator equal to 0. 2x plus 4 equals 0. Subtract 4 from both sides. And we get 2x equals negative 4. Divide both sides by 2. X equals negative 2. So I have 1, 0, one undefined value. Negative 8 was my 0. Negative 2 is my undefined value. So my intervals are negative infinity to negative 8, negative 8 to negative 2, and negative 2 to infinity. I will choose a number in each interval. I will evaluate the left-hand side. I will draw a conclusion. Okay, in my first interval, I'm going to choose negative 10. In my second interval, I'll choose negative 4. In my third interval, I'll choose 0. So remember, this is our original left-hand side. If I substitute in negative 10, I'm doing the opposite of negative 10, minus 8, over 2 times negative 10 plus 4, or 10 minus 8 over negative 20 plus 4, or 2 over negative 16, which simplifies to negative 1/8, which is the same as negative 0.125. So negative 0.125. When I do the same process for negative 4, that left-hand side evaluates to 1. When I substitute in 0, I get negative 2. So my first interval leads to negative numbers, my second interval leads to positive numbers, and my third interval leads to negative numbers. In the original inequality, we wanted to know where it was greater than or equal to 0, so we're interested in the positives or 0. So that is just my one interval, but I do have to bear in mind which of those values might be a 0. So I have negative 8 to negative 2. Negative 8 is a 0, so it's included, but negative 2 is an undefined value, so it is not. And my solution goes from negative 8 to negative 2, including negative 8, but not negative 2. Okay, let's look at another one where we need to move everything to the left-hand side. 5 over x minus 3 is greater than 3 over x plus 1. I will start by subtracting 3 over x plus 1 from both sides. So 5 over x minus 3 over x plus 1 is greater than 0. My LCD will be the product of my two denominators, x minus 3 times x plus 1. So I'll set up my denominators. We know the inequality is greater than 0. Okay, so my original denominator of my first rational expression was x minus 3. I multiplied that denominator by x plus 1, so I also need to multiply the original numerator by x plus 1. So I have 5 times x plus 1 over x minus 3 times x plus 1 minus, so in my second rational expression, my original denominator was x plus 1. I multiplied it by x minus 3, and I need to multiply my original numerator by x minus 3 as well. So minus 3 times x minus 3 over x minus 3 times x plus 1. Let's distribute. We get 5x plus 5. Okay, I'm going to move the minus up so that it's right in front of the 3 and not out in front of the fraction, so that I can distribute the negative into the parentheses. Negative 3 times x minus 3x. Negative 3 times negative 3 plus 9. That is all over x minus 3 times x plus 1. And that is greater than 0. Let's combine like terms. 5x minus 3x is 2x. 5 plus 9 is 14. Over x minus 3 times x plus 1, that's greater than 0. I'm going to factor my numerator. I'm going to factor out a greatest common factor of 2. And in the parentheses, we'll go x plus 7. That didn't help, but I did want to check to make sure that nothing would cancel out or simplify, and it doesn't. So I will find my zeros by setting my numerator equal to 0. I can either set the factored one or the original one. So here I'll just put 2x plus 14, but I could have done 2 times the quantity x plus 7 as well. I'm going to subtract 14 from both sides. 2x equals negative 14. Divide both sides by 2. X equals negative 7. That's my 0. For my undefined value, I will set both of my denominator factors equal to 0. So x minus 3 equals 0. X plus 1 equals 0. I'll add 3 to both sides. X equals 3. I will subtract 1 from both sides. X equals negative 1. So I have 1 0 and 2 undefined values. So from smallest to largest, I have negative 7, negative 1, and 3. I am going to be interested in the positives. So one interval is negative infinity to negative 7. Then I have negative 7 to negative 1, negative 1 to 3, and 3 to infinity. I will choose a number in each interval, evaluate the left-hand side, draw a conclusion. In my first interval, I will choose negative 10. In my second interval, I will choose negative 5. In my third interval, I'll choose 0. In my fourth interval, I'll choose 5. Remember, you can choose any number in those intervals, and don't choose an endpoint. So when I substitute in negative 10, for the left-hand side, I do 2 times negative 10 plus 14 over negative 10 minus 3 times negative 10 plus 1, or negative 20 plus 14 over negative 13 times negative 9, or negative 6 over 117, which is approximately equal to negative 0.0513. So it's not exactly, but it's about what it's equal. So I have about negative 0.0513, but what is important is that it's negative. When I substitute in -5, my left-hand side evaluates to 0.125, which is positive. When I substitute in 0, I get -4.6 repeating, which is a negative number. When I substitute in +5, I get 2, which is a positive number. And remember, we were interested in the positives. So second interval and the third interval. I don't want my zeros here, so I'm not including anything. So my solution is -7 to -1, union 3 to infinity. Okay, one more example. This looks harder, but it's actually simpler than some of the last couple because I've already factored everything in. I already have one rational expression on the left-hand side and 0 on the right-hand side. So I have x squared times 3 plus x times x plus 4 all over x plus 5 times x minus 1 is greater than or equal to 0. So let's find my zeros by setting each of my numerator factors equal to 0. X squared equals 0. 3 plus x equals 0. X plus 4 equals 0. In the first one, I'll square root both sides. X equals plus or minus 0, but because it's 0, that just means x equals 0. I will subtract 3 from both sides here and get x equals -3. I'll subtract 4 and get x equals -4. So I have 3 zeros, 0, -3, and -4. To find my undefined values, I'll set each of my denominator factors equal to 0. So x plus 5 equals 0, x minus 1 equals 0. I'll first subtract 5 from both sides, x equals -5. I'll add 1 to both sides, x equals 1. So I have 3 zeros, 2 undefined values. In order from smallest to largest, I have -5, -4, -3, 0, 1. That's 5 critical values. I'm going to have 6 intervals. And I'm going to be looking for the positives or zeros. And 0 is a 0, -3 is a 0, -4 is a 0. So I have an interval of -infinity to -5, -5 to -4, -4 to -3, -3 to 0, 0 to 1, and 1 to infinity. I'll choose a number in each interval. I'll evaluate the left-hand side, and I'll draw a conclusion. In my first interval, I'm going to choose -10. In my second interval, I'm going to choose -4.5. In my third interval, I'll choose -3.5. In my fourth, I'll choose -1. In my fifth, I'll choose 0.5. And in my last interval, I'll choose the number 5. When I substitute these in for x into the left-hand side, -10 yields approximately, so about, not exactly, 76.364, which is a positive number. When I substitute in -4.5, I get about -5.523, which is a negative number. When I substitute in -3.5, I get about I get about 0.4537, which is positive. When I substitute in -1, I get -0.75, which is negative. When I substitute in 0.5, I get about -1.432, which is negative. And when I substitute in 5, I get 45, which is positive. So remember, I was looking for the positives, and I think, or 0. So I've got my first interval, my third interval, and my last interval. My solution will be from -infinity to -5. -5 was an undefined value, so it's not included. Union, -4 to -3, Negative 4 and negative 3 were both zeros, so they are both included. Union 1 to infinity. 1 was an undefined value, it's not included. But, so this one's interesting because remember we are including all the zeros. And the zeros were 0, negative 3, and negative 4. So I have negative 3, I have negative 4, I don't have 0. So 0 is not part of one of the intervals that led to positive left-hand side values. But I do need to include just the value 0. And I do that by using the set of 0 with the curly braces. So this is my solution. It looks a little strange, but I have from negative infinity to negative 5, union negative 4 to negative 3, including both of those endpoints, union just the set of 0, union 1 to infinity.